All right, gang, we are going to find the second derivative of this. And these second derivatives, now that we know all the rules plus the chain rule, we've entered Hellville. This is going to get quite messy. So as you can tell, I have my paper sideways because hopefully at home, if you're doing this with me, you have some poster board because this is going to get quite extensive. All right, so overall, when we take the derivative of this, we should be seeing this as strictly chain, right? Let me just write it the other way because some of you like it that way. All right, so you got the outermost layer, the middle layer, and the innermost layer. All right, you know what I'm thinking. I'm thinking my sense of humor is coming out here. All right, so this is the Tootsie Pop, right? You start with the outermost layer, which is a 2. You bring the 2 down in front. You keep everything else the same. That gets rid of that. Now you take the derivative of secant. Derivative of secant is secant tan, but you're stuck with whatever the any is. You got to carry it along. So it's secant pi x tan pi x, right? It's got to be the secant tan of whatever your luggage is. All right, now the secant's gone. Now we're left with pi x. Derivative of that is pi. All right, let's make this guy look pretty. So we're going to multiply the 2 times the pi. We've got 2 secants. And we've got a tangent. When you're going for the second derivative, you definitely want to put the first derivative in the best format possible for you to take the second derivative. Okay? So like you're going in to do something that is challenging, you want to make sure that you're setting yourself up in the most friendly, easiest, amicable way to go into the second derivative, okay? You don't want to have it in a format where you feel like you're jumping off a cliff, right? You want it as friendly as possible. Okay, so this secant tan is as friendly as I can get it. All right, so now we're going into the second derivative. So as I go into the second derivative, I have to decide what kind of rules I have. So that idea of what's the forest, what's the trees, you have to figure out the overarching rule. So since I have a variable times a variable, the overarching rule is product. And I have I'm going to have a subset of chain because these are both composites. Okay, this is going to be enormous. Here we go. I'm going to take all of this as like my first function and all of this is my second. Technically, you could take the 2 pi out and throw it back in at the end, but I don't want to do that because some people will think I just did a magic trick. All right, so here we go. I'm thinking product rule. So first times the derivative of the second. Now, this is a composite, so I have to use chain. This is the outer layer, this is the inner layer. So here I go. Derivative of the outer layer, derivative of tangent is secant squared, keeping the any the same. Now times the derivative of the any. All right, so this is the derivative of g. So first, product rule, first times the derivative of the second plus, this was all the derivative of the second function. Okay, first times derivative of second plus now second as is times the derivative of the first function. Now the first function is very similar to this, it just has like a constant multiplier in front. That's okay. So it's the same idea. You have the 3 layers, right? The outer one is the 2, the middle is the secant, the innermost is a pi x. Okay, that's your Tootsie Pop. So here we go. Yes, I know I'm driving you crazy, and unfortunately I'm enjoying it a little too much. All right, so we'll bring the 2 down in front. It's going to multiply by this stuff here. So 2 times 2 pi is 4 pi. That's taking care of the derivative of the 2. Okay, that's the derivative of the 2. So now the 2 is gone. I'm a little afraid to cross it out, but I think I should. All right, now the 2 is gone, and technically this is gone. So in your brain, you've got now this left. So now you're working on the secant. So derivative of the secant is secant tan. All right, so it's secant. I don't know if you can even see all the way over here. Okay, secant pi x tan pi x. That's the middle layer. And I think I can fit it on the paper. So now the secant's gone. And now derivative of pi x is pi Guys, this makes you feel like you're getting a PhD at the moment here. All right, that. Okay, and that's the derivative. The derivative's done. First, product rule. First times second plus second times derivative first. Holy cow. If you're not impressed with being in calculus, I don't know. I mean, because this is impressive. Okay, now it's smush time. Here we go. Let's start smushing. What will smush here? 2 times pi. Okay, so we've got 2 pi. The pi is squared because you got 2 of them. You got 4 secants. Okay, over here I go for the little bits first. A 4 and a pi and a pi. So that's 4. My God, this video is like already at 6 minutes on one problem. This is a 4 pi squared. All right, who wants to be friends? Secants want to be friends. Who else? Tangents. All right, did I get everybody? Is anybody else lost floating in space here? No. Okay. Woo! All right. Oh man. All right, let's just do it. I know you're thinking, is it over yet? And it really sort of is. It really sort of is, but let's just go for the home run here. Let's take out the common factor. Okay, so we're going to take out a 2 pi squared. Let's take out a secant squared. And we're left with secant squared pi x plus 2 tangent squared pi x. Okay. Could you use an identity here? Yes, you could. Am I going to? No. No, I'm not going to. I'm going to leave it here. If you're having a ball, a fantastic time, you feel like the party's just started, feel free to keep dancing. I'm going to stop it here and call it a day. This, my friends, is the second derivative of secant squared pi x. I think I'm going to end the lecture on this note. Have a beautiful day, gang. Bye-bye.